Hello everyone, in this video we will learn the principle of how injection for liquid chromatography is accomplished. Shown here is commonly seen 6-port injector for liquid chromatography. On the left side is a picture depicting the face of the injector, and the right one illustrates the back side of the injector. As reflected by the face picture of the injector on the left, a dark knob is connected to the big stainless circular block. The position of the knob, either load or inject, is indicated by the label on the circular block. For the valve shown here, when the knob turns 60 degrees clockwise, it will change its position from load to inject. In the center of the circular block, there's a small hole, which is for the insertion of the needle containing sample. When the back side of the injector is shown, you will notice there are a total of 6 ports with tubings connected. No tubings are connected to port 2 and 3 intentionally to show the actual ports. Also, there are numerical values assigned and next to all ports from 1 through 6. Take a close look at the picture. You will see the numbers by the ports. Connecting port 1 and 4, there is a stainless coil which is called sample loop. The black tag on the coil indicates the volume of the sample loop. For the injector shown here, this volume is 20 microliters. For remaining 4 ports, they all connect to different parts of the instrument. For example, port 2 connects to mobile phase, port 3 connects to separation column, port 6 connects to waste, and port 5 connects to sample needle internally. Although visually only port 1 and 4 have a connection through sample loop, these ports actually connect with others internally at different positions. At the load position, port 2 and 3 internally connect, port 5 and 4 internally connect, and port 1 and 6 internally connect, as reflected by the red lines between their ports. Consequently, sample flows to port 5, then internally goes to port 4. Since port 4 and 1 are externally connected with the sample loop, the sample will gradually fill up the sample loop first, then internally goes to port 6 and eventually goes to waste. While for mobile phase, it enters port 2 first, then internally goes to port 3 and flows to separation column. To summarize these processes occurring at the load position, the mobile phase enters the separation column, and the sample fills up the sample loop and excess goes to waste. Once the knob turns to the inject position, the internal connections between ports change. At the inject position, port 1 and 2 internally connect. Port 3 and 4 internally connect, and port 5 and 6 internally connect, as reflected by the red lines between their ports. Consequently, the flows in both sample and mobile phase lines change. For sample line, sample flows from port 5 to 6 internally and then goes to waste. For mobile phase line, mobile phase flows from port 2 to 1 internally, then gradually replace the sample inside the sample loop and fills up the sample loop. Due to the internal connection between ports 3 and 4, the sample will be further pushed into the separation column by the mobile phase behind. Overall, at the inject position, we see excess sample goes to waste, and the mobile phase pushes the sample in the sample loop into the separation column. By doing so, the injection of fixed volume of sample inside the sample loop for liquid chromatography is accomplished.